So let's work on the fractional factorial design steps with an example. The steps that we have, the first step is that you want to determine the number of the runs needed for the full factorial design, which would say 2 power n. In some books, they will write it down to power k, but it's like 2 to the power of the number of the factors that you would have. And then determine the number of runs you can do, and depending on that situation that you are in for your like let's say you're working in the lab, that the number of runs that you can do is limited. Divide the full factorial run number by 2 units. It is less than or equal to the number of runs you can do. And number 4, use this as the step 4 is used as a base design from which to build the fractional factorial. So now let's have an example. We want to work on the 5 variables with only 8 runs. And when we say 5 variables, 2 power 5 is going to be 32. So we would have totally 32 runs. And then we want to see that, okay, when we are talking about that, we just can have 8 runs. Half of 32 is going to be 16. And then a quarter of 32 is going to be 8. So what are we going to do? Here, we can say that, I can write it down on the board. Let me just show you. Let's look at on the board. So we said that we have 2 power, an example, we said that we have 5 factors. So number of runs is going to be 2 power 5 is going to be 32. This 32 is the time if we had the full factorial. Right? So then, in the question, we have been told that, okay, but we just can't have 8 runs. So what are we going to do is that we say the first one is going to, the way that I would do it, this is the first time, so we would go through these steps. But generally, what you can do is that you can say, okay, so 32 divided by 8 runs, so it means that I would have like, in the denominator, I should have like 4, like it's like that 32 divided by 4 is going to be 8, right? So in that case, it means that you would need to have the quarter of this full factorial. So the way that we have it in the notes is that we would say, okay, half of this 2 power 5, and you can write down it's similar to power 5 minus 1, right? Which is going to be 16. And the other one is that 1/4 of this 2 power 5, which is going to be 2 power 5 minus 2. Right? So it's 2 power 2, so it's going to be 2 power 5 minus 2. And it's going to be equal to the 2 power 3, which is going to be 8. So I would say this is the 8 runs that we have. So this 2 power 3 is going to be your base design. So in the steps, and in the 4th step, it says that use this as the base design, right? From which to build the fractional factorial. So I would say here 2 power 3 is my base design. So now we have our base design. Or you can, the other thing that you can say here is that you can say that this is the quarter of the full factorial, or you can say it's a quarter fraction of the full design. I can write down here, it's a quarter fraction of our full design. Okay, so now let's go back to the notes. So here was the quarter of the fraction, right? Okay, let's see what do we have in the next step. We would have in next slides. We're going to have some example. Look at here. We want to build in fractional factorial with the base design of the 2 power 2. Consider again the problem of an experiment in 3 factors with only 4 runs. So it's super restrictive, the ones that we have before. So when we had if we say we have the 2 power 2 base design, so we would have the main effects here, A, B, and then their interaction, and then the treatment combination. So what are you going to do is that you say, okay, so it's negative, negative, positive, positive, and negative, positive, negative, positive. So the interaction is going to be, you're just going to multiply it, and you're going to find out the interaction. So I'm going to write it down on the board. I will pause the video, write it down, and then come back. Okay. Let's stop sharing. I just throw them on the board. So let me just. Okay. So I have like main effects of A, B, and then their interaction. The way that I'm going to do is that I will say, okay, so this one negative, negative, positive, positive, and then negative, positive, negative, positive. And then I would have their interaction, so the multiplication, whatever it is, so it's going to be positive, negative, negative, positive, right? And then I would write down the treatment combination. For example, for this one, these two are negative, so it would be 1, right? And then these two is that, like, the negative, positive, so I would have B, A, and AB, right? So this is the way that I would have it. If I had, like, I would say that for this one, 2 power 2 is my base design. So general. And we would say, okay, so let's have it for the full factorial. This is how we would write it down. Now we want to say that, okay, now I have like 3 factors, and then I have A and B, and the third factor is C. So what are we going to do is that we would say, okay, so let's say that the interaction of the AB is equal to C. So the only difference that you would see is that, first of all, it's like 2 power 3, so it's a fractional, so I can't write down like this. I will need to write down, okay, so I have like the, I would say C is equal to AB, and then here, because we have like the 3 factors, it would, and we are making that half, like the fraction of it, it would be 1 over 2, and then 2 power 3, fractional factorial. And this is going to be our principal, like the principal design, because we have the principal and we have the alternate one, and I'm going to talk about the alternate one here. So I would say 1 over 2, 2 power 3 design. And so when we look at it, look at here, instead of AB, I put down C. So here I have C as a positive one. So whatever the ones that we have here is going to change. So before, for the full one, we had 1B, A, and AB. But here, when you look at it, it's going to be, look at here, look, this one is C, right? I would write down C, and then B, negative, negative, positive, A. And for this one, it's going to be ABC. So it would be ABC. So it's C, B, A, and ABC. And I'm going to name it as the principal fraction. So I would call this one as my principal fraction. And this principal fraction, what we did was that we just said that C is equal to A and B. In fact, we assigned C to AB column. The next one is that when we are working with the like alternate fraction, alternate design that we would have, and again, the design is going to be 1 over 2. It's half of the full factorial, right? 1 over 2, 2 power 3 design. And here we would say C is equal to minus AB. So it's going to be C equal to minus AB. And this is the third table on page 13 on your notes. Again, I'm going to put the same signs, negative, negative, positive, positive. And then for here, I would write down for this one, negative, positive, negative, positive, right? And C is equal to minus of AB. So what's going to happen here is going to be negative, here is going to be positive, and here is going to be positive, and here is going to be negative, right? So it's, but when you multiply them, then you're going to multiply by the negative sign. So the treatment combination here is minus, 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 so it's going to be 1. Here is, this one is minus, positive, positive, so it's going to be BC, right? This one is positive, negative, positive, so it's going to be AC. And then this is positive, positive, negative, so it's going to be AB. So we call this one alternate fraction. So I'm going to write down here alternate fraction. Okay, so look at here. If I add this one plus this one, if I add these two, then I'm going to have the full factorial. I would say if I add this and this, here I would have full 2 power 3. Like I would have full of the full factorial design. So this is my principal fraction, this is my alternate fraction, and we're going to learn about all of these ones, like how we would work more on these ones when, like in fewer slides, maybe in 10 slides, for example. When we reach the design generators, like the table of we have a table for it, and based on that table, so in the table we have the number of the factors, number of the runs, and then we would it helps us to see that, okay, how can we get the balance and make this? This is one way of doing that. So you would say that, for example, C is, you're going to assign C to the, like the interaction of them that we would have for the 2 power 3. So here, let me share my screen again. Okay, so now let's work on it a little more. The same one that we had, like for example, for the 2 factors, which the base design is going to be 2 power 2 when we are working with the factorial design, a fractional factorial design. Let's work on it a little more to see that how can we write down the regression model for it, the basic regression model. When we have like the model for the 2 power 3 full factorial, we would say that, okay, so it's beta 0 plus beta 1 A1 plus beta 2 B, beta 1 AI plus beta 2 BI, beta 3 CI, and beta 4, so like their interaction. So we have all of the terms here, like for the full factorial. We have it in chapter 6. And we said that when we want to find out these betas, first one is the average, but the second one, like beta 1, beta 2, we would say that whatever effect that we have for like factor A divided by 2, or their interaction divided by 2, right? Now let's develop the signs for it, because we need to write down all of the signs here that we can find out the effect for it, right? So I wrote that on the board just to say sometimes for us. Let's say like this. Okay. So for AB, so we said that for the principal fraction, we had the principal fraction, and then we had the alternate fraction, right? So for the principal one, we said that C is equal to AB. Yeah. This one is C is equal to AB, and in the alternate fraction, we would say here 3 is equal to minus 3. And then for the signs, what are we going to say? We say that, okay, negative, negative, positive, positive, negative, positive, negative, positive, and then we are just going to multiply it, right? And then it's like AC, so it's going to be negative, positive, negative, positive, BC, so this one times this one, it's going to be negative, negative, positive, positive, and ABC is just multiplication of all, positive, 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 right? And then for the alternate one, what are you going to do? You can do that by yourself quickly, and it's like you would say, okay, negative, negative, positive, positive. And for this one, it's just going to be the, like it's the minus of AB, so it's going to be negative, positive, positive, negative. And then there, like you're just going to multiply it. Like for example, AC, you would say positive, negative, positive, negative, BC, and positive. It's very important that you would check it again, that you wouldn't have any typo, because whatever these signs are, you're going to find out the effects of these interaction based on that. And with that effect, you're going to find out your regression model. And then ABC, there's going to be negative, negative, and then negative, right? So when we have all of this, oh, I forgot to stop share and show you the very small. But then we can write it down like this, so you can have all of the negative sign and positive sign. Then we can write down the model for the half of the fraction of like 2 by 3 factorial. So it's like that. You're gonna add all of these, like for example, here you want to find out the effect of A. You would say, okay, so all of these negative and positive one, and then you get the average of the positive minus the average of the negative. Or you can say that, okay, contrast divided by the divisor. For the contrast, you would say all of these ones, like signs that you have in your, we call this one design table. So whatever you have in your design table, the signs that you have, we call them, we show them by Li, like I is the number of them, like first one, second one, third one, fourth one. And then you would multiply it by the Y, like the response related to this, for example, for the time that we have this negative sign. And then we are gonna, for the alternate fraction, we're going to do the same things. So when we go back to the note, you can pause the video here and write down these ones on your notes if you want, or you can develop it by yourself and just compare it with it. Go back to my notes. Okay. So when we have for the half of the fraction, like we would say half fraction of the 2 power 3 factorial, we would say, okay, so it would be beta 0 plus beta 1. Then we are going to choose one of these ones because these effects are the same, like the value of them are the same. And even when you look at it, look at here on the tables, you could see that A, and then it's like A or BC. And BC, so here, A or BC, when we are talking about the fractional one, you can see, you can compare their, the sign that they have, because A and B are the same, right? And so it's like that. For example, you would see that which ones are aliasing or which ones are the confounding ones. So what I just moved my chair. So what are we going to do is that we would say, okay, so I have my, let's say I would consider my principal fraction, and then I'm going to look at it. I would see that, okay, so A, for example, A and BC, their signs are the same. So in my regression model, as you can see here, it says that I would say beta 0 plus beta 1, A or BC, because when the signs are the same, it means that the effects of them is going to be the same. So I would write down the model the regression model, for example, for my principal fraction that we have.